Hello everyone, my name is Haoyi, and this presentation will be about Scala.js. So I work on the Dropbox web infrastructure team. Our code base has basically no Scala inside and is a large Python and CoffeeScript code base. So most of the Scala work I've done has been on the side, open source, for the last few years, and I've been contributing to Scala.js since about 2013, end of 2013. So what is Scala.js? Scala.js is a compiler that lets you turn Scala source code that looks like this into JavaScript source code, which looks like this. So both source codes look the same, except that some features in Scala, for example, over here we have destructuring a tuple to extract both elements in the tuple, do not exist in JavaScript. So over here on the right, it gets compiled into a slightly more verbose if statement, check if it's null. If it's not null, remove the elements manually, assign them to variables. If it's null, throw an exception. Semantically identical, but more verbose because of the limitations of the language. So Scala.js lets you write Scala, run JavaScript, and therefore make websites while using Scala code to implement all the interactions and logic. So the compiler will take care of everything in between writing a Scala and running a JavaScript, including compiling it, optimizing it, packaging it up, making it small and fast. It turns out to be pretty small, well, not terribly small, but it's not huge, in the hundreds of kilobytes, ungzipped. So this is about the same size as any JavaScript library, like jQuery is like 80 kilobytes unzipped. It runs about as fast as raw JavaScript, which is pretty interesting. Some benchmarks it runs faster than raw JavaScript, some benchmarks it runs slightly slower. On the whole, it's about as fast. And it supports the whole of the Scala language, including many libraries such as Shapeless or Scala-Z, or Parboiled if you like parsing, and all that sort of thing. So why Scala? Here are some reasons you may like Scala. These are reasons I like Scala. I'm not going to try and sell you too much on why Scala in general, but in general, it gives you code that's very concise. You can define abstractions that make your code more concise than most other languages. In many other languages, making code concise and making code safe is a trade-off, because the more concise it is, the less safe the code is, because it's easy to make a mistake or to misunderstand it. With Scala, you have a very strict type system, which means you can make your code both very concise while still maintaining safety. And you have good tooling and a broad ecosystem of libraries. So let's do a live demo. Over here, I have a GitHub project, which is over here. I've cloned it already. It is a small Scala.js example application. So this is the output of the Scala.js example application. It is a small hello world. I'm going to draw a pretty triangle for you demo. So let's look at the source code. We have your traditional Maven layout, source, target. SBT has project, and this is the IntelliJ thing. You need to turn on the Scala.js plugin in the project definition. And then we need, over here is just a bunch of boilerplate, name, version of a Scala compiler, etc. Let's look at the source code. The source code is Scala and resources. So this is actually a HTML page being served by a local web server from targets, Scala 2.11 classes, index.dev.html. And this HTML file lives over here. This is index.dev.html. It is a bog standard HTML file. There's nothing special. It includes a canvas which you can draw on. It includes the Scala.js compiled JavaScript file called fast.js. This is the plugin which lets me get the log spam in the browser console, kind of handy. And this is the bootstrap method that kicks off the Scala.js code. So unlike many JavaScript projects, simply including the Scala.js project doesn't start kicking things off and making everything happen. You need to run a main method. The main method, unlike a Java main method, doesn't just take an argument of a string array. In Scala.js, it can take anything. In this case, it's taking a canvas element. And this is just plain old JavaScript, getting it from the DOM. So that's what it looks like from the outside. Let's look at the inside. So here we have example.scala.js example.main. And this is calling into this file. So this file has package example, object Scala.js example, and object main. So what's interesting thing about this is that we JS export everything. And this is to say that these are the methods I could call locally. And the purpose of this is that if you don't call a method, these are methods I may call externally. And if I don't call a method externally, it is an opportunity for the Scala.js compiler to optimize away the method, either inlining it, eliminating it, all sorts of things you can do to make the code smaller and faster if it knows you're not going to call the method externally. So this is the entry point. This is the entry point method. You see that it takes a html.canvas, unlike Java main method. The name main is unimportant. I can change this to cow, and as long as I change this to also cow, it will be equivalent. And here's a small algorithm that runs every 50 milliseconds using normal DOM APIs, set interval. It runs this run method, which is here, 10 iterations of small algorithm which plots the Sierpinski triangle. So this is what the source code looks like. Let's take a look at the generated code. So Scala.js compiles code into a target folder like any other SVT project. And the generated code looks like this. So it's a lot of stuff because it includes most of the Scala standard, parts of the Scala standard library which we use. So you'll see here's the definition of Java lang number. Here you'll see the gen map factory somewhere deep inside the Scala standard library, which you normally don't care about, but is required for the code to run. So if we look at actually how much code is being downloaded, so that's, you can look at network tab refresh, you'll see that it is about 500 kilobytes. Come on, let me see how much code is being downloaded. Bigger, yeah, 550 kilobytes of JavaScript to run this page. This is under partial optimization. As you can see, the code is still very verbose. If we look at where this particular object gets compiled into, we can look here and look for a Scala.js example, and it basically becomes this area of code. So it is extremely verbose, but it's relatively straightforward. So for example, context canvas.getContext2D becomes canvas.getContext2D. Count is boxed because it gets called in a lambda. So here it becomes an interop like it does in Java land. Look at the corners definition. It is identical except much longer because all the method names are really long because we mangled them to make overloading work. Because JavaScript has no concept of overloading based on type. Scala based on Java does, so we had to make the names longer. So it's a relatively straightforward translation, even if it's extremely verbose. What's interesting is if you crunch it down. So there's another optimization step. Just now I was running fast optimization. So if I run full optimization, this will take this code and put it through a second optimization step, which involves a Google Closure compiler. So what this does is it takes all the really long method names and crunches them down to really short things, which is why it's OK to have them long initially. Takes a bit longer, not very much longer. Instead of taking 2 seconds, it takes 5 seconds. And if we look at indexop.html, here we have example opt.js taking 95 kilobytes for a hello world. Again, most of this is a standard library, so it doesn't grow quite linearly. So it's not like 50 lines is 100 kilobytes and 5,000 lines will be like 10 megabytes. But it's not tiny, but it's not huge either. It's OK. So that's how it looks like, the entire pipeline. Let's go back to fast op because it's faster to work that way. One thing I've set up is for the log spam to go to a browser and for the browser to automatically reload when the code changes. So let's see if it's done compiling. Looks like it's done compiling. So if I set this to white, you should see it compiling, and it turns white. So the Scala compiler is very slow, so the first 5 to 10 compiles will be slow. It did not turn white. OK, let's try that again. Black this time. So the first 5 to 10 compiles will be very slow, but after that it speeds up as a compiler warms up, and the compiles go to about 1 to 1.5 seconds, which is not great, but OK. So this is a live project, so one thing you could do is you could change it. So most of you wouldn't be working on websites with canvases. Most of you will be working on websites with HTML. So let's look at how we make some HTML in Scala.js. First thing, let's go to our HTML file and get rid of the canvas and convert this into a div. Looks like there's no closing element, so that's fine. And you convert this into a div as well. And first thing you realize, because I've told Scala.js that this is now a div, it can tell me that div has no element, has no attribute, get context, because divs don't, only canvases do. And similarly, it doesn't have fill style, fill rect on this context attribute it couldn't have gotten. So let's get rid of all of this. And let's go back to a very simple hello world. So in Scala.js, all the JavaScript APIs are under the DOM namespace. So you can say dom.document, you can say dom.setInterval, and they do what you expect them to do in JavaScript. So here's a doc for setInterval, for example. So I can say dom. alert, hello, and that will print out an alert. Next time reloads, poof. So I can say, similarly, the canvas is a HTML div, which is the alias for HTML div element. And if I say canvas, I can use all the attributes that are normally available on the HTML div element. For example, I can set its text content to hello. Let's rename canvas. Let's call it container because it's no longer canvas, actually. So I can set its text content to h1 hello. And this does as you expect. Because I'm saying text content, it gets escaped and doesn't become a HTML tag. If I want it to become HTML, I'll set it in a HTML. And this will do what we would expect, big hello. So those of you who have done web development will know that working like this is kind of fragile. For example, if I end up like interpolating strings, like if I have a custom message in here, I want to interpolate, and the message is equal to like script tag, alert, script tag, this could potentially compromise your application by getting the person access to all your users' cookies and credentials. So there are other ways you can do. You can create HTML in Scala.js, one of which is a library called Scala tags. So Scala tags is a DSL, which basically lets you take Scala source code that looks like this and convert it to HTML, generate the HTML that looks like this. You replace the angle brackets with round brackets, but other than that, it's basically identical. And it handles all the messy escaping and XSS avoidance for you. So I'm going to add Scala tags to my project. And this is how you do it. So let's close this because I don't need it anymore. I'll go to my build file, add Scala tags to a project, and I'll need to reload the SBT process. So now, once this is done reloading, I should be able to say import Scala tags JS DOM. So there's multiple versions. There's one version that generates only text. There's one version that generates live DOM elements. So I'm going to use a JS DOM version that generates live DOM elements. And I'm going to say, let's empty this out. And let's say container.append child div h1 hello world, and then pim cow. And then we can make cow a variable if we want. Cow. Let me put the cow here. And why is it complaining? It's complaining because the types don't match up. I have to click render on these fragments before they become real DOM elements. So now I've clicked render. It should have recompiled and become hello world, I am cow. So this is how you generally generate HTML in Scala tags, in Scala.js. It's very concise, it's type safe somewhat, so if you mistype something, you will get a compilation error rather than a runtime error. I could set properties. For example, I could set background color equals red. I don't actually know if this works. Let's see if this works. Background color equals red, missing a quote. Yeah, this works. I can misspell background color, it will be okay. It will not let me run it because it knows what it has a big list of all the possible styles that it knows about. And if you want to make a style it doesn't know about, you can, but by default, it will tell you, it'll error out if you try to use a style it doesn't know about. So here we have a hello world. Let's make it a bit less pretty, less ugly. So let's look for, what do you call it, pure CSS, let's say. And this fellow has something I can copy and paste into my HTML page, so I don't need to look at Times New Roman all day. So I put this here, I go back to my example, I refresh, and now it's using a different font. It looks about the same, actually. And let's try to make this do things. For example, let's say I want an input box. I can put an input box. Let's get rid of the paragraph because that's not exciting. And let's get rid of the... So I have an input box. This input box doesn't currently do anything because I didn't make it do anything. One way you can make input box do something is to get a reference to it, put the reference into the DOM, and then let's say on mouse up, and then that will happen every time I make a change. alert, let's say my input.value. So it's complaining because when you say dom.alert, as I mentioned earlier, it should compile. And now when I change something, it alerts nothing. What is happening? It's not alerting like it should. Okay, this is very annoying. Let's try console logging it instead. So input, oh, I use on mouse up, no wonder. So when I click and let go, it will console log. Let's try on key up. So all these are standard properties in the JavaScript DOM. We have modeled them in Scala.js, so Scala.js knows about them. Here we are, that's more useful. So let's say I don't want to console.log this. I want to put this in output somewhere. I can create another element. My output equals div.render. I'm going to put my output below my input. And I'm going to say, instead of console logging it, I'm going to say my output dot, what do I want? I want the text content is equal to my input.value. Dun, dun, dun. Why is it complaining? My output, you put this above so it compiler's happy. And now we have input and output box. So pretty trivial to do other things. For example, to upper will make it upper. And if I want to do other things, I can do so. So one interesting thing is that I'm calling a bunch of properties on these DOM elements, but I'm only allowed to call the right property on the right DOM element. For example, I cannot call my output.value, but I can call my input.value. And that is because the compiler knows that if I render an input fragment, I get the input element. If I render a div fragment, I get a div element. And it just won't let me run the code if I make a mistake like this. Just as I showed you earlier, when I change it from a canvas to a div, it also wouldn't let me run the code. So that's kind of what Scala.js gives you. It gives you the ability to make changes and not have them blow up in your face, but have them give you nice red lines in the compiler, sorry, in the editor, without having to debug something in production. So let's make this a bit more complicated. Let's say I have a bunch of things I want to autocomplete. Let's say I have like apple, clearly not spell that right, banana, mango, mandarin. And let's say I want to make this a bit more complex. Let's say I want to output an unordered list. And I want to say for fruit in fruits, if fruit dot starts with, let's say let's say I normalize it, to lower it starts with my input dot value, and you put parens here. I guess first I need to inner HTML equals empty, and my output dot append child. Let's say in this case I want to append the list item because it's an unordered list. Why is this not lining up? This item, and I want to append the fruit name. And let's see if that works. Oops, I need to render it. So now if I type apple, mandarin, so interactive JavaScript written using Scala.js, but a lot easier than it normally is in JavaScript, simply because if I don't know what I can do to something, I can ask, and it will tell me. It will say, append child adds a node to the end of the list of children, specified parent node, etc., etc. So you don't need to keep going back and forth between MDN and your error console. You can literally work in the editor without ever looking at the documentation online. Let's say I want to split it. I can say first last equals fruit.split at, I think split at, yeah, split at my input.value.length. And I can say I'm going to make the first part background color yellow with the first part, and then let's put the second part directly after. Oops, not second, last. So now if I start writing things, you get pretty acceptable autocompleter in a very small amount of lines of code with no libraries. So one of the interesting things is that when you start working with Scala.js, you realize you don't need jQuery anymore, because the DOM is actually not bad to use as long as you have documentation tell you what does what and what you can do with things. So with Scala.js, you can. I can just append things. I can check their values. I don't need to use $.val, paren. I can just say get value, and if it's the wrong thing, it won't let me run it. So that's kind of what the experience using Scala.js is like. And let's go back to slides. So some notes for demo. The turnaround time was OK at the end. At first, it started off pretty slow, about 5 seconds. It's annoying. But by the end of the demo, it was around 1 second or so turnaround because the compiler had warmed up. You get compile errors when you make a mistake, which are very nice. You get accurate in-editor autocomplete. So if you're trying to explore things, yes. Any editor which works with Scala. As far as IntelliJ is concerned, it doesn't know it's Scala.js. Yeah, so Eclipse will work, IntelliJ will work, and Enzyme should work. I don't have to use it myself, Sublime, whatever. So some of you will be wondering, like, how does Scala.js compare to all these other things? Because there's not a small number of people trying to compile to JavaScript. Like at Dropbox, our web code base is all in CoffeeScript, for example. We converted 2 years ago, was much better in JavaScript. Now it's beginning to show its age. And there are many other things that people have tried. So if you look through all these, I've not looked through all of them, like written in them for 2 years, but I have looked through them. And you realize that everyone wants the same few features, more or less. Everyone wants your code to be safer, so you don't get this kind of error turning up in production after all your names have been minified and you don't know what the hell's going on. Everyone wants to write fewer lines of code to do simple things. Everyone wants to not have to re-implement things twice. This is one of my pieces of code at Dropbox, which I re-implemented twice. It was very annoying to re-implement because the numeric behavior of Python and CoffeeScript differ. One of them's doubles, one of them's integers, so everything just changed. Everyone wants what we call async support, but more generally, being able to turn this kind of nested callback pyramids into a nice top-to-bottom async block. Everyone wants better tooling. And for better tooling, often you need to have a more toolable language. Like IntelliJ tries very hard to make JavaScript and CoffeeScript toolable, but give tools to JavaScript and CoffeeScript. Because it's hard to do so, it only can try its best. And everyone wants fewer warts. So this is well-defined, but that doesn't mean it's reasonable. And people don't like it when you bump into this sort of thing and find out in documentation, oh, yeah, it's meant to do that, but you shouldn't do that because you actually want to do this other thing, which is way less obvious. So how does Scala.js compare to things? And again, this is much outside perspective, except for CoffeeScript, of which I've lived in for the last 1.5 years. And in general, if you look at the various bullet points that I tried to cover, feel free to call me out on any of these if you think it's a mistake. But generally, you have the untyped improvements to JavaScript, which, because they're untyped, often end up just being not very toolable. You can't build easy autocomplete for CoffeeScript any more than you can for JavaScript. But maybe they add a lot of things to JavaScript. For example, CoffeeScript has code which is even more concise than Scala in many cases. And ClojureScript similarly has lots of very powerful tools. And then you have the other side of the ball, where you have the typed languages like TypeScript and Dart, which often are kind of clunky to use because they made the language themselves. Dart is half JavaScript, half Java, and it really shows the half Java part. But you get types, and therefore the experience in editor is really nice. You can press dot and see what happens, whereas in JavaScript you press dot and you're just praying that you got the right thing. And in many ways, Scala.js is the only thing which hits all these categories. So when you think about it a bit deeper, what is a web application? Web applications look like this. You have a database, which is always colored blue, not always. You have a bunch of web servers which talk to the database. And you have a bunch of browsers which talk to the web servers, preferably more than one browser, otherwise you're going to lose money. And your browsers talk to different servers because that's the way the web is. And normally on the front end, you get HTML, JavaScript, and CSS. This is an open web. And this is basically how almost all web applications look. You may have Flash, you may have Silverlight. Those are dying right now. You may have stateful servers. Those aren't very common. Almost everyone uses this technology on the front end. But when you look at what it takes to do things on the front end, I have 150,000 line of code base in CoffeeScript at work. It often looks like this. So your server, ours is Python, which is not bad. Maybe yours is written in Haskell or Scala with Scala Z, very safe. Cannot make runtime error. So it doesn't matter how safe your server is if everything in front is ready to explode when you make the first mistake. So HTML, you make a typo, your page looks all wrong, your CSS doesn't work properly, your JavaScript can't find the elements, everything breaks. JavaScript, you make a typo, everything breaks. CSS, you remove a rule, everything doesn't break, but all your buttons are off screen, so no one can click the buttons. And then you have your Ajax layer, which is even worse, because while your JavaScript, at least you have linter, almost no one has an Ajax linter to make sure URLs line up with your routing file in your server-side code base. So with Scala.js, we brought safety to the JavaScript. No more stupid errors in JavaScript because of typos. The editor will tell you and you'll have to fix it before you can run the code. But what about the rest of the things? So one thing we also have is typed HTML in a way. So this is what I showed you earlier. This compiles to this. Not very interesting. What's more interesting is what happens when you screw it up. So when you do this, value elf is not a member of object float. Very helpful error message, and it's a compilation error message. What if I screw this up? Not found value to v, also compilation error message. So that's one thing that we've managed to knock out of the park, and you basically don't worry about XSS or unformed HTML when working with Scala.js. So another thing, CSS. With Scala.js, one thing that we've set up is that let's you write your CSS. We let you write your CSS. This is purely a library. This is not core to the language itself, but just to the library that I made. You can write your CSS in a way that looks like CSS, more or less, compiles to CSS, more or less, compiles to Hygienic CSS, so you'll never get a class name collision, which is, I don't know if you guys have had problems with class name collisions. I've had many problems. You call your thing modal, well, I'll call my thing modal too, bang, or both modals look terrible. This ensures Scala.js's CSS support, well, one of the library CSS support ensures that every CSS class is fully qualified based on the Scala package, Scala class name, and CSS definition name. So package simple button is not just button, so even if you use button somewhere else, it won't collide. Typos get caught in the same way as I showed you earlier. Maybe not so exciting by now, but coming from CSS background in Dropbox, everything breaks pretty often. And let's say you want to use the CSS you just defined. Well, one way you could do it is you could manually splice the fully qualified names of the generated classes into your fragment. This does work and generates a fragment like this. More interestingly, we've set it up such that you can directly splice the objects from your CSS trait into your HTML fragment. And you will know that it works because if the object doesn't exist, it will raise a compile error. So for example, let's take this example here. I can't copy and paste this. I'll just rewrite it. So let's say I am in my code here. I want to say trait simple. I think I need to first import Scala tags dot style sheet everything. Extend style sheet. Yeah, I'll put this inside here. I need to say val simple equals sheet of simple. So there's a bit of boilerplate. Button equals class, color red, height 125, and let's say def fade equals class.hover. Opacity goes to 0.5. So when I hover over anything with fade, it will fade, which kind of makes sense. So now I have this. Let's go back to the HTML page. So nothing has happened yet because I defined a style sheet. I have not used it. I can print out dom.console.log simple.style sheet text. So this is not being printed out. Here we are. So this is basically what I showed you earlier instead of PKG's example, Scala.js example, blah. Let's say I add this to the DOM. So dom.document.create element style val my style my style dot inner. I guess I don't know whether text content or inner text. Let's say text content for now. We'll see if it works. And then dom.document.head.append child my style. So all this is just plain old JavaScript. I'm just sticking it in the head. Compile, it works, nothing has happened because I haven't used the styles anywhere. So I could copy and paste the example dash Scala.js example dash button dash simple dash button, or I could simply take the object I've created and say simple dot. This is not really a button, but let's just call it a button. And let's call this, let's give my output simple.fade. So now it's red, now it's 125 pixels high. Now the output, where's my output? Output has disappeared. Well, let's put fade somewhere else. Let's put fade on the title as well. Simple.fade. So now I mouse over, it fades. It's kind of cute. I guess import simple everything, and then it'll be a bit more concise. So now it's just button and fade, which is like just as concise as you would if you've used strings, but when you inspect the generated HTML, it uses the fully qualified names. Wrong window, this one. When you inspect the generated HTML, it uses the fully qualified names such that it will never collide with people. And as you'd expect, if I change this, the compiler will yell at me and not let me run my code, which is probably what I want. So if you want to change and refactor your thing, for example, this is not really a button anymore. This is more like title style. Then you save it, compile, it works. And when you inspect this, now it says, I should open it up before inspecting. Here we are. Now it says simple dash title sound, simple dash button. So is this kind of safety which Scala.js gives you at CSS, which is pretty unique. I haven't seen it. I honestly haven't seen it anywhere else. Being able to have both hygienic CSS and kind of typed CSS, so that if you delete something that you shouldn't have deleted, or you remove or you rename something and forget to rename all the call sites, it will tell you, and it will not let you do so until you fix everything. And by the time you fix everything, it's almost guaranteed to be correct. It's kind of nice. Over here, we have a bit of boilerplate, but this is all one boilerplate, constant amount of boilerplate for as many rules as you want, so it's okay. If you really don't like it, you can put in the function. It's not a big deal either. So that's hygienic CSS. Last thing, Ajax calls. What about this huge danger point here between our very safe client and our very safe server? Don't know. Well, one way you could do Ajax calls in Scala.js is the same way you do Ajax calls in Scala in JavaScript. So the left-hand side is JavaScript. The right-hand side is Scala.js. It looks about the same. Who can tell me what's wrong with this code? It's buggy. Well, let's ask the compiler what's wrong with this code. So I'm going to import dom.all var xhr equals new XML HTTP request. I can put this, I cannot put it. xhr.open http bit.ly xhr.onload equals x dom.event arrow xhr.send. And then we print out print line done. So I didn't know what's wrong with this code. Turns out that we are missing the method argument on open, which is nice of the compiler to tell me. So I guess I went get. And when I run this, it's probably going to give me some. It's going to give me some CORS error because I'm not allowed to get to that website. So let's try hitting localhost instead of going to the worldwide internet. So localhost and done. So quite literally, at the base level, Scala.js code looks identical to JavaScript because Scala.js and JavaScript, they both have arrow functions, they both have dots for properties, they both have assignments, they both have vars. This one actually doesn't need to be a var, this can be a val because it's immutable. You're not changing it. But it's immaterial. But no one actually does JavaScript Ajax calls like this because it's kind of a pain to keep doing that. So like a Dropbox, we call our jQuery $J because it conflicts with some other thing we have. And most people have something like this for their Ajax calls. $.ajax, the URL. I pass in the data. Maybe it's a struct, maybe it's a string. And on complete, I get a function that gives something back. And all these things are kind of unchecked. So if I mistype list here, nothing will happen until I get a 404 at runtime. If I thought it was taking a string, but actually takes a struct of 2 strings, similarly, it will not tell me until it breaks at runtime. Maybe in production, maybe when you're on call and asleep at 2 a.m. So the way you do it, one way you can do Ajax calls in Scala.js is like this. So you basically say Ajax to the API trait. I want the list method. I pass an argument and call it. So to begin with, this is about 1/4 lines of code. But that's not the interesting part. The interesting thing part is, first, it returns a future. So a future is like a JavaScript promise. It's basically equivalent to JavaScript promise. It says that I don't have the return value now, but I will have it at some point in the future, and you can like have a callback, or you could chain it or something. Let's say the list endpoint returns a sequence of strings. Let's say the list endpoint returns a sequence of strings on the server. I don't need to worry about serializing into JSON and back. I immediately get a sequence of strings on the client, in the future at least. So it's not directly a sequence of strings. But when you try to screw this up, it also doesn't let you. So wrong arguments. I tried to use it as a wrong thing. I forgot it was asynchronous. I thought it was just giving me the value. Actually, it's not, and it won't let me use it. And all this requires a small amount of boilerplate for you to define what the list endpoint does. So all of you have heard of the client-server interface before. And in Scala.js, the client-server interface can quite literally be an interface. In Scala, interfaces are called traits. Just spelled differently, they're effectively the same. And the nice thing about making a client-server interface a Scala interface instead of some Google Doc somewhere is that your compiler can understand a Scala interface, and a compiler does not understand Google Docs. So the compiler can actually check the client-server interface is correct and doing the right thing. So you do have to spell it out. You do have to spell out the API. The API trait has this function that takes in a string and returns a sequence of strings. But when the time comes to say, I want to make sure my server matches that interface, what do? I simply extend the API trait, and if I screw it up, the compiler will yell at me, you are not extending that interface correctly, please fix it. So like, for example, I want to change the server endpoint. What will happen? Compile error. Method list is not, the API is not defined, blah, blah, blah. OK, I need to add it to the API trait according to compile error. So I add it to the API trait. Are we done? We're not done, because now on the client side, it's going to yell at me, because on the client side, now knows that it takes 2 arguments, and I only provided 1. So I give it a second argument. And are we done? We're not done, because this should be a string. So this is the kind of thing that Scala.js lets you do that, as far as I know, almost no other platform lets you do. It gives you very high degrees of confidence that all these traditionally very flaky things will work. And you do have to do some amount of plumbing underneath to make sure the bits end up in the right place. But once you've done that plumbing, adding a new method to an API is as simple as adding a new thing to the trait and then fixing all the compilation errors until it works. And similarly, refactoring the API is equally simple. So I am at the 30-something minute mark. So let's just take a look at a live demo. So git branch. Let's reset all the work I did here. Let's look at this branch. I can't spell because it's very cold. OK, so here we are. And now this guy is going to have to reload the project. And let's say I want to, I think this example, JVM / restart every time the code. So this tells it to restart the server every time the code changes. So here is a not quite minimal, but nice small example of a shared client-server application implemented in Scala.js. So in this folder, go away. In this folder, I have a JavaScript subproject. I have a JVM subproject. I have a shared subproject. And if I go to the website, which I believe is now localhost 8080 according to what the log spam said, I basically get a file browser, which is minimum amount of logic to show that something is working that's not purely in the browser. So if I look at target, there'll be a lot more stuff. Yeah, so that's all the Scala compilation rubbish being left there. So what does this code look like? This code, if you look at the JavaScript subproject, is similar to what I showed you earlier. You have an input box, output box. You append this stuff to the DOM. Whenever you have a key up in the input box, you update output, which is here, which is this block, and then make an Ajax request using the same syntax I showed you earlier. Instead of calling Ajax, I called it client. It's just a spelling. It's not important. And I get the result back, which is a sequence of paths, sequence of strings which are the paths, and I stick it in the DOM. So this is the boilerplate I mentioned earlier, having to make sure it goes to the right server with the right prefix, encoded in the right way, etc. And if you look at the server, I basically have an equivalent thing, which is here is the HTML page. So Scala.js lets you write. So this is using the same library that I showed you earlier to generate HTML on the client as DOM elements, except I can also use it on the server to generate HTML as plain text, as strings. And Scala.js lets you write a library that can use on both client and server, which is kind of neat. So this is now the exact same syntax from the same library used on the server to generate the HTML page. And I basically have a small HTTP server that takes any path under API and forwards it to my router, which stuffs it into the, how should I say this? Which puts it into the server object itself and calls the correct method on the API trait of the server. So over here I'm saying, give me the route this request to the server object, which is this object itself. And it will automatically call the same the correct method on the server and return the result and unserialize, serialize, whatever. I configured which serializer to use here. You could use any serializer that works on both JavaScript and on the JVM. So again, upickle is this one, and micropickle, which is this one, are also both the same library. Same serialization library, implemented once, compiled, run twice. And what happens is that you basically get Ajax calls for free. If I look at network tab and look at what's happening in list calls, you'll see that I'm making nice not quite RESTful, but JSON RPC requests to /API/example /API endpoint /list. And the request is, where is the request? The request should be somewhere in here. But the response is also nicely formatted JSON. And as far as your code is concerned, like on the client, this is all done automatically here. And when you actually do the API call, you don't need to worry about formatting or unformatting at all. You don't get back a JSON array. You get back a Scala seek strongly typed. If you futz it up, the compiler will tell you. And if I want to like rename this, like moo, let's see what happens. So rename. Are we done yet? Compile, fast optimize, done. Let's reload the page. Now, all the endpoints are going to moo. So single action rename of a Ajax endpoint across both client and server. And the last thing I haven't showed you so far is the shared folder, which quite literally contains the shared interface between client and server. So the interface between client and server is an interface, and not only is interface, it's also shared. But luckily, Scala.js gives you a very convenient place to put shared code, which is in a folder called shared. And you can share anything here. I already showed you sharing the templating library, sharing the serialization library. You can also share data structures. I could define my own case class here. File data, let's call it name, string, size, int. Let's say I want to return file data. So the first thing that's going to happen is it's going to blow up because I have lots of compilation errors. So now it knows that I need to return file data. Let's go and fix all the call sites. So let's say files.filter.map path goes to file data of path. Let's just call it 0 size for now, just 'cause I don't feel like filling it in. Are we done yet? We're not done yet because this guy needs to be updated, file data. And then the client will need to be updated too. So this is no longer path. This is now file data object, and the editor knows, and the editor is already telling me that I'm using it wrong. So let's call it data. Sorry, what am I doing? And you do data dot, what does it have? Data dot name dash data dot size. Let's bold the name. Cool. So now we're done. It finally compiled. And now when I look, now everything is size 0 because I was lazy on the server. But you look at the JSON that's being passed back and forth. It's not quite automagically, but pretty magically being updated to represent a JSON object array being passed back and forth. And it wouldn't let me compile it otherwise. And I know it works, because if it didn't work, the compiler would not let me. So let's go back to the slides. Where were my slides? Here they are. So if you look at what is a web application, what Scala.js gives you is a lot more than safety in JavaScript or a fancy new language that you have to go and teach all your people. It also gives you safety everywhere else on the client in a way that I've not seen anything else do, any other language do. So not only have we safeified the JavaScript, we have also made safe the HTML, made safe the CSS, and made safe the Ajax calls between the client and server. So that's actually quite a lot of things that are traditionally very fragile and are now no longer fragile, or don't need to be fragile. So mission accomplished. So I haven't talked a lot about Scala, but Scala.js basically gives you everything that ES6 gives you in terms of string interpolation, const classes, arrow functions, whatever you want. You probably have it already. It gives you everything that TypeScript gives you in terms of like type annotations and generics and whatnot. It gives you monads and higher kinded types and all those fancy things, but you don't need to care about that if you don't want to. I haven't used any of them so far in this presentation. More importantly is what Scala.js does not give you and does not let you do. And that's probably more important than what it does give you. So it does not let you make typos that result in undefined is not a function sometime at runtime. At least not easily. You can force it to, but that's with a bunch of effort. It doesn't let you create and malform HTML if you do the right thing. It doesn't, if you use the libraries that we've built, you can have no unused CSS classes, no using of missing CSS classes. So no, like, I think this CSS class does something, but actually doesn't do anything because I deleted it a year ago. And no CSS classing collisions, no malform Ajax requests, which is pretty sweet. And these are pretty nice. So in conclusion, like Scala.js gives you a bunch of safety. It is very expressive. It gives you some nice tools. But most importantly, it gives you a sense of safety throughout your whole JavaScript application, your whole client-server web application, CSS, HTML, everything, that you didn't make a fat finger that will blow everything up. And it doesn't give you 100% safety, but gives you quite a lot compared to what you have by traditional tools. And even though it's not that mature, we've had most of these features for the past 12 months. So it's not something you need to wait 6 months, 2 years in the future for some ES7 standards committee to standardize. Like, you can have this now, you can debug it now. If you throw an exception now, you get nice stack traces because of source maps. Let's see if this works. Yeah. Oh, this one doesn't have source map set up. Anyway, if you throw exceptions, you get source maps. If you want to use third-party code, we have people using React and Angular. I haven't used them much myself with regard to Scala.js. We use React a lot at Dropbox, but that's in CoffeeScript. But yeah, so that is what Scala.js is all about. And any questions? One sec. Microphone.
One of the problems you have with any of these strongly typed things that compile down to JavaScript is you have an impedance mismatch. You see this with TypeScript. You'll see this with JavaScript or Scala.js. So one of the problems here that I would run into, if I'm doing Angular, for instance, the types are not going to be present in the third-party library, which means somebody has to write those type bindings. Do you have an example of what those look like? I understand a lot of them are already written for here, but I mean, how difficult is it to write your own?
Sure. So let's look at Scala.js Angular. So it is made by some guy in Korea. And let's see if I can find the interesting bits to show you. Not interesting, not interesting. OK, so this is not quite what I want to show you. Let's look at a different set of type bindings. Let's look at, so this project is a 2D game I made using Scala.js, just to show you what it is. And I did not implement the physics myself. I use a third-party physics library called chipmunk.js. And the library is written in JavaScript, so I had to write bindings to it. So let's look at Scala. CP stands for chipmunk, facades. So basically what third-party bindings look like is I need to define a type, and I need to define what it can do. And all the rest is question mark, question mark, question mark, undefined, basically. And anything of this type will automatically get transformed into JavaScript calls when you compile a Scala.js program. So for example, a chipmunk.js shape has these methods you can call on it. I know that, for example, the update method takes a vect, but a chipmunk.js vect is this and has x and y both mutable. And so this is what bindings look like. Further example, if we look at the DOM bindings are not special. They're also a set of third-party JavaScript bindings. So if you look at the document, so this is saying that the DOM object, which has an attribute called document, the document attribute is of type HTML document, which has all these properties. Because it's of type HTML document, it has the body property, which is of type HTML element. And because of type HTML element, it has the append child method. So basically, it involves sitting down and transcribing things from documentation. The DOM ones were transcribed from Mozilla Development Network by me. I also did the chipmunk.js ones. Other people have done React.js, Angular. More generally, if your JavaScript library is strongly-ish typed, it is much easier than if it's JavaScript-ish typed. So for example, if you look at Scala.js jQuery, because jQuery is one of those JavaScript libraries which takes anything and returns who knows, depending on what you pass in. Scala.js jQuery, half of the types are any, because it can't tell you what it's going to return, who knows. But for something like the DOM or for something like Chipmunk, which was ported from a C library, the types are pretty standardized and pretty sane. Yeah. Questions?
Also, just to follow up, I recently did a Scala.js project, and one thing is you can invoke any method or any property you want, even if it's not defined. You just don't get any type safety from it, which is worth knowing. You know,
I can show you. So let's say I want to look at this project again, and I say input box. So by default, it's typed. I can cast it to js.dynamic, which is basically saying, YOLO, I know what I'm doing. And then after your JS dynamic, you can do whatever the hell you want. And when it compiles and runs, it will blow up at runtime. So if you don't want to actually put in effort to write a full-blown set of facades, you can do this. You can do this, but actually this doesn't blow up. This just returns undefined. I think I have to do this to make it blow up, because JavaScript's like that. So compile. Yeah, can't read property of undefined. So for one-off things, I want to access this property. I know it's there. I don't want to go and bother writing a facade for it. Just cast a dynamic and do whatever you want. And you do lose type safety. And if I want to do anything with the result of this, it's now dynamic. So I have to do extra as instance of again to bring it back into Scala land. Yeah. Any other questions?
Yeah, I just wanted to ask. First of all, I want to say that I recently did a project with this, and I was amazed at how well it worked.
Yeah, thanks.
It worked. I know you shouldn't be amazed when things that actually work, but I really was.
Sure.
But I was wondering if you could comment, what is the community like? Are people using it yet, or are you starting to see that happen? Or
so
not?
We've got a bunch of people using it in production, small number in small companies. I don't know of any huge company that decided to pick it up yet. The community is still in the early adopter, I'm willing to beat through problems phase, and which is quite nice because when they have problems, they'll fix it rather than complaining to me and the other people who help build the project. If we want to estimate how many lines of code has been written, I would say about 1 million in total. The biggest projects I know of are about 10 to 20,000 lines of code, and then there's a long tail of smaller projects, and probably about 1 million lines in total, given 100 people of doing that. Because most people who build stuff don't actually come back and tell you. So I would say maybe 1 million lines of code has been written, which is not huge, but it's okay. Questions? Back here.
Right, so one piece of pushback I can see getting from this, and I wonder if you've thought about this, is with type-safe HTML,
yes,
I can no longer take the HTML and give it to my designer.
Yes. Right,
because they don't want to work with Scala, they want to work with straight HTML.
Yes.
So have you run into any of that, and how have you dealt with that?
So at Dropbox, we don't use Scala.js. We use CoffeeScript and Python, and we don't have that problem at all because none of our designers want to work with our web code base. And many of our engineers also don't want to work with the web code base, but they have to. So we've never had a case where the designer will put together a beautiful HTML mock and we'll splat it into the code base unchanged. Currently, it's almost always, here are some mocks, and you have to transcribe it manually. So I never really thought of that as a problem. Yeah.
Okay, so not solved at all.
Not solved, yeah. Go for it.
Because I was thinking about the same issue earlier, is it practical to develop in Scala, save off the HTML, and then pass that to your designers?
I think it wasn't your question. Designers would generate the HTML and pass it to us, developers. Is that correct?
That was, yeah. That was
yeah.
I totally misunderstood your question, so
yeah.
Never mind.
Mm-hmm. Any other questions? Okay, I think we are done. Thank you.